Solving exponential equations, example 4. Find algebraically the exact points of intersection of y equals e to the x plus 1 and y equals 6 take away 4e to the negative x. So we want to solve these simultaneously, and they both say y equals. Now that's nice because that means I can just do e to the x plus 1 is equal to 6 take away 4e to the negative x. Let's bring everything to one side. So e to the x, take away 6 from both sides, take away 5, add 4e to the negative x would be equal to 0. Now I'm going to multiply right through by e to the x. E to the x multiplied by e to the x, think about it, add the indices, is e to the 2x. Then we'll have 5e to the x, and this will just become 4. E to the negative x times e to the x, add the indices, negative x plus x is 0, e to the 0 is 1. So, e to the 2x can be written as e to the x squared. Think about the index law. So what I'm going to do here is let y be equal to e to the x, and then we'll have y squared minus 5y plus 4 is equal to 0. And that's a quadratic. We can factorize that. So I've got y take away 4 and y take away 1. So y is equal to 4, or y is equal to 1. And remember, that means that e to the x is equal to 4, or e to the x is equal to 1. Well, this one here would give me that x is equal to 0, e to the 0 is equal to 1. And for this one here, take the natural log of both sides, we'd get x is equal to ln 4. Now we want the coordinates. So if x is ln 4, I'm going to say y is equal to e to the ln 4 plus 1. Remember that the exponential and the log are inverse functions, so that's just 4 plus 1, which is equal to 5. So we can say that one of the points is ln 4, 5. And if x is 0, y equals e to the 0 plus 1. So y is going to be 1 plus 1, and therefore y is 2. And so we have the point 0, 2.